In today's lesson, we are going to be looking at unit fractions. So to start off, a little bit of an activity. We're basically going to write down what each section or each portion of our strip here represents. So if our main one represents 1, what does the next one represent? We use different colors here, but if I look at the next one, I've basically divided it into 2. So basically it's a half in each section. The third one, that 1 is now divided into 3, so it's 1/3 in each section. The next one is divided into 4, so 1/4. And we can kind of continue this down. 1/4, we have 1/5, 1/6, 1/7, 1/8. I'm running out of 1/9. 1/10. 1/11. And 1/12. So again, that's just looking at basically recognizing the different fractions going from a whole. And the reason that we're doing that is because we are going to look at kind of how these kind of unit fractions compare. So moving on to our note, we completed the fractions strips on the previous page. Now we want to look at which one is bigger, 1/6 or 1/8. Well, if you go back and look at the page, and you can even see a bit here, 1/6 is larger than 1/8. 1/7 or 1/9, 1/7 is larger. So those ones are usually a little bit easy. When we have just basically one of something, the smaller the number means it's a larger or represents a larger amount, right? If you think of a pizza, 1/2 of a pizza is larger than 1/3 of the pizza, and so on. Next, we're looking at 3/6 or 5/10. So this one might be a little bit tricky. Well, 3/6, what does that represent? We could look at it here. 3/6 represents basically half, and 5/10 also represents a half. So these are the same, right? These are equivalent. They're the same amount. Are there any fractions equivalent to 4/8? Well, we just kind of talked about that, right? 4/8, if you think of, I have 4 out of 8 total parts, this is the same as saying 1/2, and we've talked about that. That's the same as also saying 3/6, 5/10. So now what I want you to do is to go back to your fraction strips page and see if there are any more sets of equivalent fractions. Are there other values that are the same? You might find some like saying 1/4 is the same as 2/8. You might see that 1/3 is the same as 2/6, or is the same as 3/9. Right, so go back and take a look at the fractions strips page and see if you can come up with other sets of equivalent fractions, or basically fractions that equal each other. Can you create a few more pairs of equivalent fractions using numbers greater than 25? So can you go up to, or use basically, if I was to divide the strip up into more than 25 parts, or less than 25, or sorry, more than 25 parts in general, can you come up with more equivalent fractions? So I challenge you to try to do that on your own in your spare time. Next, we're going to look and kind of go back to the unit or the ruler measurements, or measuring in the metric system, or sorry, the imperial system, because when we're measuring things in the imperial system, we tend to use parts of an inch, and they can go anywhere from 1/2 to 1/16 of an inch. So we're just going to kind of go back and review that. So below, we're going to label the 1/8 parts of the inches. So basically we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and a whole. we're going to relabel the eighths parts using as many unit fractions as possible. So rather than have 2 of eighths or 3/8 or 4/8, we're going to have it where it's a 1 on top or a numerator on top. So we have a new kind of definition here, unit fractions. A unit fraction is a fraction with a 1 in the numerator. So if I go back and look at this, I have 1/8, there's a 1 on top. 2/8 can be written as 1/4. 3/8 can't be written as anything else. 4/8 could be 1/2. 5/8, 6/8 can't be written as a fraction, but we could write it as something smaller if we wanted to. We could write it as 3/4 if we did want to, and then 7/8. So below, we're just going to, again, you can relabel it again if you want, or basically what we want to do is we want to draw a line segment from 0 to 5/8. So we use the example above. I'm not going to draw through those, but if I was to draw it to 5/8, it would look something like, oops, too far. Something like that is 5/8. So you can go back to your fraction strips page, and is the 1/6 marking equivalent to anything with a smaller denominator? And if it is, this is a reduced fraction or a fraction in the simplest form. We kind of have already done that. We've kind of jumped the gun a bit on that because we've realized that I can reduce this to 3/4, right? Or it's a fraction in its simplest terms. So below, can we label the 16th part of an inch expressing fractions in a reduced form? So on the 1/16, 2/16, we zoom in a bit to make it a little bit easier. Might have to use a smaller font size. So 1/16, 2/16, 3/16, 4/16, and so on. So again, you can go through and do this as well, or just recognize what each piece represents. And in the next one, basically rewrite that, except, oops, I lost everything there. You can rewrite that using reduced fractions or unit fractions as much as possible to make it a little simpler. Well, 1/16 we can't reduce any further. The next line we can. 2/16 is the same as saying 1/8. 3/16 we can't. 4/16 is the same as saying 1/4. And you can see every time we see a larger or different line, we can write or reduce the fraction. So we have the smallest line, so that would be 5/16. I can't reduce that. This line is a little bit larger, so I should be able to. This is actually the next eighth, or 2/8. We have, we have 7/16, which we can't reduce. The larger line here, this is a half. So a half, then going to 9/16. It's a small line, I can't reduce it. It's a larger line. This can actually be reduced to, see if we have a half, then we have 5/8. Small line, so 11/16 we can't. A larger line, we can. This is 3/4. We have 13/16. This one we can. This would be 7/8, 15/16, and then 1. So again, it's just by recognizing that we can reduce some of these larger fractions to a simpler form. And again, you may be aware of this already, or basically if I take it out, these larger numbers are basically we're combining the different fractions that we saw in the previous one, or combining from the fraction strips. So below, we're going to draw a line to 7/16. So again, it's just understanding where that is. So if I draw a line to 7/16, I know that's going to be 1 before half, so it should end there. Draw a line to 3/4. Again, I have my previous one, so it would be out to there. We can write that down just to represent 7/16, 3/4. So what I want to do is draw a line for each measurement of the following. 2 1/8 of an inch. So 2 1/8. 1 1/2. So we're going to 1 1/2. 1 3/16. So 1, 1, 2, 3/16. 3 lines. 2 1/8. So 2. 16th is the smallest one. 8th is the largest one. So a large one right there would be 1/8. Or you could think of it as 2 2/16. Can you find a difference by measuring with different parts of an inch ruler? So if we look at it, we can say, okay, this is approximately just above 1 1/4 inch. When we get some more lines in there, or basically smaller fractions, okay, this is 1 and above, so just almost 1 3/8 of an inch. Here we can see, okay, this is exactly 1 and 1, 2, 3, 4, 1 5/16 of an inch. So this line is 1 5/16. The next one, so this is just almost 3/4, almost, or just above 1, 2, 3, 4, just above 5/8. And again, here, if we look at it specifically, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is actually 11/16. So we're close, but again, obviously, the most accurate representation we get is when we're dealing with 16th parts of an inch. So again, obviously, the more parts we break it down into, the more accurate we can be. Next, we want to calculate the perimeter of the figure, and we're going to measure each side to the nearest 1/8 of an inch. So I do have my ruler here. It doesn't really help us because there's no numbers, but we can at least use it to kind of approximate as much as possible. So we started at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually this isn't going to quite work because this ruler doesn't quite work. But again, go through, use your ruler, use the nearest 1/8 of an inch. So you're not using the smallest one, you're using the second smallest one. Describe how you would tell someone to label the 1/8 and 3/8 on a 16th parts of an inch ruler. So basically, if I wanted to say what does 1/8 equal in terms of 16ths, well, 1/8, I can change my font size back a bit. So 1/8, 1/8 I can say is actually works out to 2/16. And 3/8 actually works out to 6/16. And you might be like, well, how did I get those numbers? Well, in equivalent fractions, you can think about, okay, what did I multiply 8 by to get to 16? I multiplied by 2. So what do I multiply 1 by? I multiply it by 2 as well. From 3 to 16, from 8 to 16, I multiply by 2. So to get the top number, multiply 3 by 2. Here we're going to calculate the perimeter of a triangle with side lengths 5 3/4 of an inch, 2 1/8 of an inch, and 4 3/16 of an inch by first expressing each side as a 16th part of an inch measurement. So I can use the ruler as an aid, but 5 3/4 basically works out to 5. What do I multiply 4 by to get to 16? Because I know I'm going to 16 parts, or 16th parts. I multiply it by 4. So to get an equivalent fraction, I have to multiply the top number by the same thing as well, which would be 4. 3 times 4 is 12. The next one, 2 1/8. We've just kind of done this conversion in the last one. I want it to be 2 and something over 16. 16ths of an inch. What do I multiply 8 by to get to 16? I multiply by 2. So I must multiply the top number by 2 as well to make it equivalent, which is 2. And then finally, 4 3/16 is already in that form. So if I want to find the perimeter, I have 5, 2, and 4. So I have 11 full inches, and 12, 2, and 3/16. So 12 plus 2 plus 3. 12 plus 2 is 14, plus 3 is 17. So I have 11 and 17/16 of an inch. I can remove or change this improper fraction. There's actually a full inch there, so it's actually 12 and 1/16 of an inch. So again, just a lot of basically working with fractions, converting between equivalent fractions, and then even adding fractions there, or converting from improper to mixed. Based on what you know about parts of a whole, which slice of pizza would be bigger? One slice of pizza cut into 8 pizzas, or one slice of the same pizza cut into 12? Well, the pizza cut into 8 is larger. Or we should say not the pizzas are the same size, but the pizza slice from the cut into 8 is larger. Because the smaller the number or the denominator, or the smaller or the fewer number of pieces it's broken up into, the larger each piece is. For 5, shade 1/2 of each circle and use it to represent an equivalent fraction of 1/2. So if I want to shade in 1/2, this is divided up into 6, so I need to shade in 3 pieces. Here it's divided into 4, so I need to shade in 1/2, which is 2. Next, can you shade half of this circle and use it to express an equivalent fraction of 1/2 without decimals? So if I look at this, I have 1, 2, 3, 4, 5, 6, 7 slices. So if I wanted to divide this up into half, or to shade it into half, what I could do is, it's hard to find 3.5 slices, but I could cut everything up again into halves, basically doubling the amount of slices to 14. But now it's a little bit easier to shade it in, because I can shade in exactly 1, 2, 3, 4, 5, 6, 7 slices. So I can shade in 7 slices. So instead of basically doing 3.5 out of 7, I can shade 7 out of 14, which is the same as 1/2. So again, what we're doing in this lesson is basically just working with unit fractions, basically fractions that have a 1 in the numerator, as well as looking at equivalent fractions. So fractions that represent the same amount.